I'm going to be talking about a tool that we developed that is being used in the field by Maryland State Highways Administration, their specifically the Motor Carrier Division, and Maryland State Police's Commercial Vehicle Enforcement Division to help keep the freight in their region under control. So why do they need to do this? What's the problem with freight? Trucks are heavy, and our infrastructure is only capable of handling so much. We need to protect our bridges and off-ramps from overly heavy vehicles damaging them, and we need to protect those vehicles from themselves. Each vehicle is only rated to carry so much, though if you pack it in, you can get a lot more in there a lot of the times, and that can put strain on the axles, cause the brakes to not work as expected. You're going over a bridge and you've off-balanced the load somewhat. It's easy to topple, and that would just ruin everyone's day. So the way we deal with this in policy is we make sure that every vehicle is rated for the appropriate amount of weight it can carry, and we license the drivers that they're approved to operate that vehicle, and we make sure that the companies that are going to use those vehicles are also properly certified. Problem is, freight is a business, and if you can, if you're running a milk truck company, and it's just a big cylinder on the back. Just by looking at it, you can't tell if you're a few 100 pounds overweight or not. But if you're going to get into an accident, that's going to make a big difference. So you hope that something bad doesn't happen, and you run heavy, and you hope you can get away with it and make a little extra money by delivering more. So we have weigh stations out there, physical parking facilities with scales, and we have little signs on the highway that tell people, hey, weigh station active, you need to pull over for your truck and get weighed to verify that you're doing right by us. The problem is they're physical facilities, and you can only build them in so many different locations, and it's very easy to oftentimes find routes around them. So this map actually shows the location of two in Maryland. That's Baltimore up in the top right, DC down the bottom left. We've got the weigh station down there at the 495 interchange, and one up on 29. If you're coming out of Baltimore, you can just take 95 south, cut over on 32 and take 29 the rest of the way down to the Beltway, and you bypass the need to stop at any weigh station. We can't exactly very quickly deploy a new facility. We can't knock out a couple acres of land on 32 to work around the freight companies that have figured out how to do this. But what we can do is deploy a virtual weigh station there. And the way these virtual stations work is it's weigh in motion. So it's a set of detectors that are on the roadway and a camera. When a vehicle crosses the detector, it is weighed based on the timing of when the vehicle is crossing the edges of the sensor. It's able to detect the weight and classification of the vehicle, how the weight is distributed across the axles, and if it's a freight, the camera will go off and an image will be snapped. We kind of just ignore the passenger vehicles because they're not so important for Maryland State Police in this particular project. Compared to the process of actually paving over some forest, this is actually a much cheaper and relatively quicker process to set up. So the truck continues off down the road after being weighed and flagged, and unfortunately for him, there's a police officer sitting a quarter mile downstream with an application on his phone or a website on his computer that the University of Maryland has developed. It's updated in real time, and he can decide if the readings coming off of that sensor to his laptop are high enough that he wants to actually flag this guy down and take him to the physical weigh station and force him to offload some of his cargo and fine him as appropriate. So I'm going to switch over and do a demo of the application that Maryland State Police has available to them in their vehicles. And there's also, this website also works on the mobile devices as well. So they have the option of choosing whether or not they want to use their laptop or their iPad or phone. So this is a part of RIDIS. So after they log in, those Maryland State Police officers will see a link for the virtual way station application. Here's a list of the different locations where there are virtuals deployed. The US 301 Bay Bridge location was actually destroyed recently by a construction crew who didn't realize it was there. I think we had a talk about that earlier in the session about how that could be avoided in the future, but they're currently repairing that. So I can pull up one of these. I've got one here. This is Maryland 32. We are looking at a vehicle that crossed the station here. Aspect ratio is a little funny. Let's see if I can hide this. A little more space. There we go. Alright, so it looks like it kind of dodged the camera a little bit there, but we're looking at a vehicle that went by at 1:54 local time there. It's a class 6, it's a dump truck. The front is off balance, that's what the magenta there indicates. The back wheels are heavy. The size of the circle there represents how much of the load on that particular set of axles is distributed. So it looks like all the weight, and you can kind of tell by the image too, is kind of distributed towards the back. But other than the fact that this vehicle is off balance, there's no other flag thrown. Let's see what else we got here. That's another off balance. Here we go. This truck is running heavy. You've got the red there indicating which axles are overweight. The bright red represents the fact that that particular axle is completely overweight. It is beyond the legal limits, and the lighter red indicates that that is getting high but not over that threshold yet. This updates in real time. I've got a filter set so that I'm only looking at violations. So just the guys who are in trouble, I can remove that filter. And I can also remove my filter on class 2 vehicles. So this is the passenger cars. They don't get their pictures snapped as well. But we can see them streaming by, and we get the way station information there as well. So they'll use this device on their phone. They'll lock to the vehicle that they want to flag down, and they'll go over to the driver after they flagged him, and they'll have a little discussion. So it's not just stuff that happens on the side of the road, though, that they're concerned about. Maryland State Police also wants to identify repeat offenders. So they needed a tool that would allow them to look at trends in how people are kind of abusing the roadway system. So we put together this little analytics tool here that on the left side gives them the ability to specify what it is they want to search by. So I can choose the date range I'm interested in. I've already done this search. I've prepared the results here. Which of the stations I want to look at, I've gone and selected all of them. Which vehicle classes. So typically class 9s, 9 and up are the ones they're concerned with. And these are all of the flags that the virtual way stations pick up. So I can say, maybe I don't care if someone is trying to cheat at the way station by slamming on their brakes at the last second. That's that speed change flag is. Or if they're following too close to the vehicle behind them. But I've gone ahead and just pulled in everything. I'm looking at one of the many visualizations that's available here. I've got vehicle count by date and hour. So I've got hour of day along the top, and each day in the time period I searched along the vertical. So I can mouse over any one of those and see just how many vehicles there were that came within that hour time band. Now we can see where the distribution of the vehicles is. It looks like at this particular station we expect to see the most vehicles of the type that I've filtered there coming by during the evening hours. Let's see just looking at the class 9s that are overweight gets us at this particular station. While that So on this list, one of the options is a table with vehicles with nested axle details. This is kind of a prescribed report that Maryland State Police told us that they were already told they needed to provide to their superiors, that they're basically doing by hand. And so we wanted to give them a way to quickly do this with the data that they were providing to us through the virtual way station. So it's nothing too complicated. We list the vehicle identification number, so that's basically a random number assigned to a vehicle by the way station, the time that the vehicle crossed the sensor, vehicle class, number of axles, and the weight distribution across the axles. Any part of the vehicle's identifying information that triggers a violation is colored in red, so you can very quickly, if you've got the vehicle in mind, find out exactly what might have been up with it. We can click on any one of them and it'll pull up the details. This one was one that went by at night, so our color isn't really working there too well. It's just black and white. We've got the image there, and we see the wheel, the particular axle that is overweight. There looks like everything's kind of shifted towards the front of the trailer for this particular, in this particular case. Back here. All right, so this is finished. So I've just filtered out class 9s that are overweight. So if I were a state police officer looking to target this location, it would tell me that contrary to the previous query I ran where everything was kind of cluttered in the PM peak, it looks like the middle of the day is actually the best time to catch class 9 vehicles that are abusing this section of roadway. There are a number of other visualizations in here. This one is kind of fun. It's a time spiral. So we've got the first day in the date range in the center, and the outermost ring represents the last date, and it's kind of a 24-hour clock. So each little colored widget on there represents a vehicle going by the station that matches the flags that I've set on the left. Maryland State Police has admitted that this visualization is not particularly useful to them. It works with other data sets, but not really so much with point in time. But they've said it's kind of cool for coolness sake. And when I recommended removing it, they said, no, you should just keep that, we'll play with it. So they have that available to them. And they have a number of kind of bar charts that allow them to go in and get kind of more categorical data. So we can see how that works. Clicking on any one of the, it'll come back in a moment, resulting bars. I've just filtered class 9, so that makes sense. Let's undo that. Clicking on any one of the bars that comes up will bring up a list of the vehicles that match that filter. So it will be a particular hour of day and day of week, particular number of classes that I've selected, a particular number of flags, and I get all of the vehicles that match that. So I can see the profile of all of these. These are basically my top offenders for the date range I've selected. I can click on any one of these links, get the detailed picture, and there's actually a pre-populated field notice. This is something that Maryland State Police wanted to put together so they could just print out this little letter, stick it in the mailbox, and send it out to the company that is running this truck, and in kind of not so subtle language, I don't think, indicate to the carrier that they need to make some changes. So it basically says, this is not a traffic citation, but you're basically breaking the law, so you need to contact us so we can check out what's going on with your vehicles. So they're using that pretty actively. The tickets that they collect for these things run in the thousands of dollars a lot of times. So the virtual way stations actually pay for themselves very quickly. They have 6 deployed right now, and they are looking to triple that by the end of next year. So I promised during my lightning round that I would give some more stories, and I'm not going to spend too long on this because I have a flight that is sooner than I realized. Maryland had 5 of these stations deployed initially, and a few months later they started one on I-83, which is north of Baltimore going into Pennsylvania. So people were figuring out that there was some kind of technology that was on the road that was measuring them on the routes where the virtuals had been deployed for a few months, because they were getting pulled over shortly after. So they started trying to pick out what they looked like, try and spot the camera. And during one of these, the construction process on I-83, someone must have recognized the camera that they were installing as one of the ones from the other locations, because when they opened it up on the day that they activated the site, they had someone within the first 2 hours decide they did not want to go through the virtual, probably because they were running heavy and didn't want to get caught. So they took the exit before the station, wound up in a residential neighborhood. This is a tractor trailer. Should absolutely not have been there. Couldn't take the curves of the residential streets properly. Ran aground in the mud in a police officer's front yard. And so he had to help him get out of his front yard, and then ticked him for so much more than he would have if he had just run the virtual way station overweight. And I also promised I would talk about watermelon buses. This is a creation of Delaware. It's kind of a more agricultural state than Maryland, at least compared to some of the larger cities, a lot more farming land. So what they do in Delaware on the farms is to ship their produce. They will take decommissioned school buses, shave the top off them, as you see here, so they can get expanded capacity, I guess. And they'll drive them throughout the state and into other states. Delaware's cool with this because it's kind of their economy. It's what they do. Maryland, not so much. When police officers started seeing these things on the roadway in their states, in Maryland, my first reaction was, I think that's breaking a few laws, but I'm not exactly sure which ones. So they basically tried to, in the words of the police officer I was speaking to, love these things to death. So they couldn't just outright ban them, but they decided they would make them get special permits to run like this, and they just made them pretty much impossible for these buses to pass the inspections that would allow them to get permits. It's dangerous running these things over the Bay Bridge because you hit a bump, one of those watermelons is going flying. You do not want that on the Bay Bridge. So, over the years where they've been denying people permits for watermelon buses, they've actually had to grant someone one. They had to relent. A bus actually passed adequately through the inspection process. However, using the virtual way stations, they noticed that there were multiple watermelon buses running by these stations per day. So clearly, there were people who were taking advantage of the fact that they knew that there was a license for a watermelon bus around there, but not necessarily for theirs. So that is actually something Maryland State Police are currently dealing with, trying to track down who is taking advantage of this. So it explains the price of watermelon in Maryland, I guess. Looking forward, some of the things that we're looking forward to doing with them. Maryland State Highway Administration is currently evaluating license plate reader vendors. So we'll be getting data off of the virtual way stations that indicate who actually owns each truck that's going by, so we can very easily identify repeat offenders. And as I mentioned, by the end of next year, they're looking to triple the amount of installs that they have. That is all I have. Does anyone have any questions? Yes?
I knew Class 15 is the unclassified vehicles. What do they use Class 14 for?
I'm not exactly familiar with the vehicle classes. Yeah, Class 15 is an error code in their system.
So 14 usually is a special type of custom vehicle. I don't know if it's the watermelon bus, but
maybe.
But also, I wanted to add that buses are extremely heavy. You showed the Class 9s, the axle weights are like 20 kips. The RT
quick question. Did you have any problems getting data from the vendor feeding the feed to you for that, or how did that work for you?
Just technical hurdles in getting everything working, but
They let you.
yeah, as
access
far
their
as
data.
Mountain State Highway facilitated it.
Okay.
They made sure the vendor
Right.
was willing and able to provide it to other people before they sign on with the
Who's
vendor.
the vendor?
It's Cardinal Way Station is the name of it.
So this is being used for compliance and enforcement, but only after that particular property carrier is interdicted by a patrol officer, who then kind of replicates the process by taking them to an official way station.
They'll send out those pre-populated field notices just to anyone that they see.
Which is kind of a warning.
Yeah, so they
I mean,
won't
that's just a
necessarily
warning.
have
It
a.
doesn't enter into their MIGMAS or whatever their record.
No.
It-
It's a courtesy, they call it.
A courtesy, I like that. The second thing is that the watermelon vehicle would be officially, I think, a passenger carrier.
Class 4.
Because it was originally constructed for that purpose.
Yeah.
And the FMVSS, which NHTSA has responsibility for, would still apply. So that technically, any and all of those vehicles are,
Passengers?
yes, they have to be, I think, enforced or inspected according to their original configuration. Is that, do you know the?
I can see
think
that.
that is the.
All the records there are going in as class 4, so just as a bus, right? So.
Yeah, it's a bus, and it's still, whenever seats are taken out or any of that, that's a violation of the FMVSS. Because it's a modification. So, the virtual way station is a great way, I mean, you can catch every single one of them.
I like watermelon buses though. We should convert our buses.
We should.
Yes.
Michael, the expansion plans, do you know if that's going to include Interstate 70 and 81?
I'm not sure exactly which locations they've targeted. I'd say with the number that they're deploying it, it's probably likely.
The State Highway Administration has decided now that they like us handling their way station, their virtual way station data, so they're now starting to push us all of their regular way station data as well. And there's some other analytics we'll probably be adding into that at some point.
These are all loop piezo weight stations. The weight sensors is a piezo.
Yes, yes, and they
No
have
bending plates, no.
not that I'm aware of, and I know they have a special truck that they run over them fairly regularly to calibrate them.
From what you've shown us, what's the split between the vendor and the university? Who's done what with this technology?
The vendor actually put together kind of a rudimentary version of the analytics that we have. Is that table that I showed was something the vendor had originally developed and they want us to include. But as far as what Maryland State Police is using now, the vendor is really just providing the data coming off the sensor. They use us strictly for the front end.
So the vendor installed everything. And the main reason why we're doing this is the vendor's solution, it uses wireless modems out in the field to communicate back. They actually have their own little server in each box, but they were only allowing one person to connect at a time because of bandwidth issues and other stuff. And, well, we have hundreds of people who want to see this at a time sometimes. So they send the data to us, we're the one person, and we have tons of bandwidth and other resources. And
I can tell you that all the vendors are good at the hardware, the sensor side. But the software side, they're all very poor. And, they need a lot of help. That's not where their money is, right? Their money is on maintaining, operating the sensors.
And speaking of money, this is a real low budget project. This is no rocket science here. I think it was in the low tens of thousands of dollars to put it together.
With the software, is that something that Maryland may be willing to share with other states?
We would definitely entertain taking data from other states and just reusing the software. That's kind of what we do. We're like a data warehousing place. So absolutely.
What Maryland, is it Highway Patrol?
It's the motor carrier safety division of.
Will they have plan for you to also integrate their pre-pass data? You know, they have this responders and.
They're not doing that right now. I know Maryland, I can't tell you why, but Maryland for some reason is not happy with pre-pass right now. I think they feel as if more people are getting by than ought to be.
Yeah.
But I don't know much about that, and I don't think there's any plans to integrate right now. That's a private.
Make a lot of sense.
It does make a lot of sense,
to
but
integrate.
pre-pass is a private company.
I think, if I remember correctly, pre-pass might not allow that as part of their agreements, at least in North Carolina. So North Carolina went with NORPAS for that reason.
Right.
So it.
I mean, just
but
the
considering-
solution, you know, the pre-clearance.
The
of-
idea,
right,
yeah.
right.
That makes sense.
Right.
Especially once we get the license plate recognition. Because we can't actually tell who's out there right now. You have to look at a picture.
Yeah.
But once the LPR is in place, then there's more capacity to do that sort of thing.
Yeah, that's gonna be neat. We're gonna do all kinds of different visualizations once we've got IDs on people.
So the vendor will install the, Cardinal will install the license plate, or you guys are?
No, we don't install any hardware out in the field. And I don't know if Cardinal's the one that's doing it or if it's a third party. I'm not sure. We'd have to check with our main point of contact.
Thanks.
All right, well, hello everyone. Thanks for staying. Got about half an hour left. I'll try to make it quick, leave some time for John. My name is Greg Ferrara. I am a program manager at ITRI, the Institute for Transportation Research and Education at NC State University. I'm actually going to be presenting to you this rather long title. I decided to not go ahead and repeat it, but I'll just let the presentation speak for itself. What you're about to witness is a distracted driver causing a crash. Hey, did you see that? It was very close. I'll replay it again for the sake of time. Very early on, and if you caught it, Alina was looking at Daddy. Looking at her
Did you
sister.
have your children stage that? Just
No,
for
I just happened to.
Blur out the faces too.
Yeah.
But they had helmets on, so.
They did.
Yeah.
Yes, it was good.
We see your priority was
Offender
putting on film.
Child abuse.
Well, as difficult as this may be to conceive, risky driver behavior, such as the one you just saw, it actually cascades out to other vehicle types besides bicycles, passenger vehicles as well as trucks. In fact, these are leading causes of truck crashes or critical reasons for truck crashes. Truck crashes are actually a very small part of the overall crash percentage of 3%, but if you get in a wreck with a crash, wreck with a truck, your chances of it being fatal skyrocket. And because most trucks involved actually have more than one vehicle in a crash with a truck, and because of this, the cars are those other types. Passenger vehicles are other types of vehicles that are involved with a truck, and they are the critical reasons most of the time for a truck crash. If it's a fatal crash, that actually goes up to 75%, more or less. These are varying stats from varying sources, fluctuates, but it's about that. And of course, to mitigate this problem, obvious like any complex problem requires complex solutions. Education, enforcement, and engineering are the three big ones. In North Carolina, We have a motor carrier enforcement program, as Michael Van Daneker stated. Every state does have such a program, and they're actually administered under different umbrellas within the states. In North Carolina, that's administered by the North Carolina State Highway Patrol, what is called MCE. They are actually responsible for enforcing the safety and weight regulations in the state. MCE is geographically spread out across a large area in North Carolina and is comprised of only a small portion of the Highway Patrol, so a lot on their plate. And these geographic areas are called troops. They're multi-county areas and are actually quite large in North Carolina. The motor carrier enforcement program is split up into two sections: CMV safety, where the troopers are really required to enforce and regulate and really bring down and drive down truck fatalities. And they also have to, and are really charged with protecting the road infrastructure. These basically, the states have measurable goals and objectives that are set forth by the funding sponsors, the federal government agencies. On the safety side, it's FMCSA, and on the weight side, FHWA, through joint agreements between the state and the feds. And where really the feds are really interested in outcomes are king. These performance-based funding models are really becoming the norm now, with FMCSA already having those in place on the safety side, and the weight side, FHWA, coming into play with MAP 21. And really the states really have a good driving force for this, because as performance-based funding models, the option to kind of pull back that funding does exist and has been a reality in some cases. As I said, my name is Greg Ferrara, work at NC State University at ITRI. ITRI is the university partner with the North Carolina State Highway Patrol. We've been providing technical support and program evaluation support to that program, the MCE program, since 2001 on the safety side, on the motor carrier, on the FHWA weight side since about 2007. We operate the Commercial Vehicle Enforcement Resource Lab. It is an actual North Carolina-based, at the moment, resource for the North Carolina State Highway Patrol. Our mission is to increase enforcement effectiveness through decision support technologies, data analysis, research, and education. And we've really taken the approach of driving enforcement down to the troop level. These individual troops are all uniquely different. They've got individual different geographies, industries in every troop, and collectively they're all responsible for their part of the collective state responsibility of that performance, because the state is responsible for those performance-based. So we've really tackled that at the troop level and really going to that in that direction. You know, this kind of really is a matter of going beyond just counting the number of crashes that occurred in your troop, or the number of enforcement activities, and kind of the driving force behind this is to work smarter and not harder. And that really kind of brings you to, and really our role is to try to engage the troopers, the troop supervisors, that's our target audience, the middle managers, if you will, in these business units, to look at data relationships. You know, where are we enforcing versus where should we be enforcing, or how should we be enforcing? Are we targeting the right areas and the right activities? To that end, for the past year, we've started to develop a sort of an analytic platform called CoverLab Analytics. This platform, we're in sort of version 1.0 right now. We've begun that, got troop feedback, and are actually involved with rolling out 2.0 at the moment. So I'm going to show you real briefly what our 1.0 looks like and how we kind of how the troops are actually using this at that level. The first part is, hey, how am I doing in my troop? how am I performing against those measurable goals and objectives that the state's responsible for? So we provide the troops their own individual scorecard, they've got their own login, we're tracking those performance measures that are set forth in the enforcement plans. We provide them with clickable deep dynamic reports that they can report out to the state quarterly, and we even augment and use some of these reports to help the state level report out to the feds. And then secondly, where they're underperforming, we actually help them improve their, or prioritize and improve their performance by providing interactive visualization dashboards for context, trends and patterns, and then we've developed a map analytic platform called Vantage to have them interactively filter their crashes and enforcement and reference layers that we've developed with charts, graphs, and maps, tables all in one view, so to speak. So here's a quick example. If a trooper were to log in, troop supervisor were to log in, he might see his or the state level performance on any given performance metric. In this particular case, I'm not sure, this is, I guess we're lucky today where we have a very large screen. Over here, the metric is reduce rural CMV crashes to 2% or less as a state level. So here's the goal. This particular troop is not doing so great, Troop B, and they are at actually 3.57%. So it's kind of incumbent upon them to start looking at how they might improve this, what's going on. They may or may not be able to make a difference, but at least providing them with these data interactively can start that process going. So, quick example of a dashboard. They can kind of look at the trends overall, which are in the blue, for overall crash counts, overlaid as an example with the percent of rural fatal crashes and the percent of fatal crashes. In this case, looks like there's a little bit of a spike in, say, January, as for context. And then, kind of looking at map analytics to kind of see what's happening in their troop. Quickly at the top, choose their troop, choose time period, and then rural fatal crashes as an example. In this case, I've turned it on. I've actually not shown the points, the actual points themselves, but you can click heat map to see where those are. In this particular case, most of them happen to be here, just as a kind of visual sweep of what's going on generally. And you can kind of see as a quick, by default, dashboard view, if you will, or graph view. We've kind of put up crashes by hour of day. You can take a look at contributing circumstances by default, which is what the troop supervisors have indicated they've wanted. Quickly select any of these other ones if you wanted to change that. We've actually are now implementing, and with version 2.0, what you just saw with Michael Van Daniker's presentation, which was what we're calling a heat grid. That sort of XY heat grid with hot colors in the middle where stuff is, putting that down here. So we're actually going in that direction as well. And if we kind of go a step further, we have the sort of operational layers here, select crashes, citations, or inspections, and we can kind of click on what's happening with our citations. In this case, I've again turned off the individual points rather than be clouded with that point cloud. Here you got all the citations, how many of them are mapped, and how many of them are actually in clusters. Again, they're kind of hovering around the way stations and up near Fayetteville. There might be a reason why they're not here that we're unaware of. Maybe it's inhospitable areas for conducting inspections or issuing citations or something like that. Or maybe they just don't know what's going on with that particular area of crashes. Again, crashes by time of day relative to citations by time of day sort of have a slight difference in time period between the two. If we were to align this along with the locations, perhaps you can start to make some headway along with that. Again, citations don't necessarily, cannot necessarily be tied exactly to the crashes, but at least getting them in the ballpark is a start. Again, inspections, motor carrier enforcement actually can do inspections, pull over vehicles, as Michael was saying, inspect them without probable cause. They can just say, hey, I'm going to pull you over, I'm going to inspect you. The citations that they issue them are civil citations, and here they are. Here's what's happening for citations, for inspections as well. and we again see a similar pattern, not quite aligned. Another application for Vantage, this is kind of like the advanced version that we've got. General question, which loggers are cited the most statewide, and where are they? And quickly look at a count of those. Here it is. Answer a question very quickly if somebody were to ask that. Motor carrier enforcement troop supervisors and troops themselves, the federal government, FMCSA in particular, puts a big burden, I should say that quietly here, on the states themselves. They actually require them to reduce crashes within municipalities, even though they typically don't patrol there and are not part of their normal jurisdictional domain. So they actually conduct outreach events in cities themselves to drive those truck crashes down as much as they can in the cities. In this particular case, as an example, they might be able to use this for some of those outreach activities. In this case, the city of Fayetteville, quickly choose fatal and injury crashes, KAs and Bs, heat map it, and quickly show, hey, what's going on with the contributing circumstance as the first contributing circumstance. Disregarded traffic signals, number one, might be able to reach out, maybe even give the actual municipalities themselves access to this. But we haven't gone there yet. In addition to that, sort of a third and final example is one of the other metrics that the Motor Carrier Enforcement Unit is responsible for is conducting a certain number of inspections. Just how am I doing on the number of inspections that I've been required to do by troop? Here's the dashboard, scorecard on this side, and over here, inspections out of service. And what that is out of all the inspections that I've conducted in my troop, how many of those were put out of service? How many did I actually pull off the road because of some safety reason or driver violation that was so egregious, they said, hey, you're not going anywhere. And in this case, a quick summary of year to date. There you go. The lower the number is actually worse. In this case, Troop F is at 9.4%. And if that troop supervisor wanted to kind of drill down, they could do that. Again, quickly look at a dashboard and see general trends over my inspections over time. In this particular case, this is an out of service dashboard here. Take a look at who is actually underperforming in that regard. In other words, pulling over trucks and doing an inspection, but no violation that resulted in out of service. That did not happen. In other words, pulling over Walmart trucks, for example, great safety record. Not to say that they wouldn't be pulled out of service occasionally, but they may not be the highest of risk for that. By right-clicking on a decomposition tree, quickly take a look at the top individual troopers themselves. By number, in this particular case, that's their actual trooper ID number. That's the number of inspections that they've conducted that did not result in an out-of-service citation. And in this particular case, you can choose any number of different variables to kind of drill down by. I've chosen carrier to see who are those carriers that particular trooper is pulling over. UPS as the top dog. And I can kind of look at, well, where is that trooper conducting his inspection activities? In this particular case, he's kind of hovering around the way station. Perhaps there's easy pickings around there. I can sort of sit there and get some quick inspections, get my quota done. And I'm mostly doing that on Tuesday, Wednesday, and Thursday. I'm also over here doing that in the middle of the week. So that's a quick overview of where we stand right now. We've released the first version. We're actively working on implementing feedback we've heard from the troop supervisors, and we are working on putting that into version 2.0 at the moment. And that is scheduled for release in April 2014. We usually attempt to coincide this with a yearly conference that the actual state-level motor carrier enforcement group has within their own everybody gets together, all the troops, once a year, and we bring in speakers in a micro conference similar to this, and actually use it as an opportunity to conduct workshops and hear what they have to say and kind of feedback, and give them information that we have. So I think I'm hopefully right on time, maybe leave a minute or so for comments. We are actually, lastly, adding a size and weight scorecard because of MAP 21 requirements are coming down the pike. We're kind of a little bit ahead of that to some degree, and it hasn't quite hit yet, but we are one of 3 active participants in an FMCSA study. One of 3 states actively participating in an FMCSA study to look at the relationship between weight and safety, as well as the national efforts to increase the weight limits for our federally funded road infrastructure. And I guess we have, lastly, just some quick challenges. We need help on adoption measures. How do we actually know whether what we're doing is actually being effectively used? I know we can measure how much they're logging in, but is it actually changing their behaviors in the field? We know that they perceive that there is value for this. It looks great, sounds great. If you were to look at this and kind of intuitively, it seems like it makes sense to, once you provide data to those troops, but is it actually having an effect? And that's what we kind of want to get that baseline to start with and measure that. And we have not gone there yet. We hope to do that and start that in April when we release version 2.0. All right, that concludes my presentation. Thank you very much. I'll be willing to entertain questions for the last, give a little bit of time for John. Yes.
I guess this slide mostly answered my question. It was about what performance-based measurement or improvements have you implemented based on what you've, and it seems like that's the next step.
That is, yes.
And when I looked at your data, number one, like I said, the disregarded traffic signals in those inner city areas. And one of those that I'm seeing, you can see out here as you go on to the 405, is that trucks like trains cannot stop in the time in that dilemma zone cycle to meet the red, right? So one of the things that the traffic signal controller could be utilizing would be like, as we're seeing on those, like from the virtual weigh station, there's piezos that will give the information of the weight and the speed of the truck as it's moving into that dilemma zone to either extend the yellow or allow the green, because the trucks are so heavy that they just can't stop in time. But right now the signals are timed basically for a passenger vehicle, right? And the trucks can't meet the passenger vehicle dilemma zone criteria.
Yeah, that's a great point. Making the system more flexible.
So what I'm saying is that disregarded stop is kind of a misnomer. They cannot stop safely in that time.
Right. That's a great point. Great point. Great, thank you. Any more questions? All right, thank you very much.
So, I'm going to bring up a PowerPoint presentation to start in with a little bit. I'm going to go through this quickly. Of course, since my computer crashed, I had everything open and ready to go at the time, which now I'll open up. However, we'll try to get through it regardless and get us back on track here. So at the end of this, and I'm going to try to watch the clock, when I've got 10 minutes to go, I'm going to open up a data set and try to build out a data visualization on the fly with a interactive workbook so that you can see how this is done with the tool, and again, encourage you to go build some of this stuff out yourself, because there's data that you have that you probably haven't been able to get answers from right now. So I've kind of titled this Transportation Data Visualization for the rest of us. So I'm going to blow through some slides pretty quickly here. I already talked about who logistics is a little bit. Today's takeaway is that I can do that. I want you guys to know that you can do that. So Again, we do a lot of supply chain network analytics, merger acquisition studies, advanced business analytics, site location. We work with site location specialists, that kind of stuff with our analysis. But most of it involves transportation of freight, whether that's rail, truck, whatever it is. So we don't deal with the highway network itself and the level that you do, but we deal with transportation. So we do these kinds of things. We use a variety of tools. Some on the left doing Monte Carlo simulations. We may just be plotting out, this happens to be a particular supply chain with all the various modes of transportation to get from plant to the DC or the customer. And we model all those things discretely in models in our supply chain optimization studies. That kind of a model will look more like this, so it gets a little more complicated in terms of all the links and nodes that connect it together. And then we have to be able to display that back to the customer, so sometimes we use the software that I'm going to talk about, which is Tableau software. So if you've not used it, you can download a free copy. You can use Tableau Public, particularly if it's public data. There are a lot of bloggers, news organizations, and others that you can upload something like a gigabyte of data to their public site and do it that way. So kind of the traditional approach was you really needed your IT staff, your operations research folks to build out detailed content-specific applications for you to be able to load your data to it. And they were detailed, accurate, and customized, and often had long development cycles, needed substantial support staff, and in some cases quite a bit of development money to get done. They're all good. We have some of those things. I mean, this is kind of a density map of a data set that we were bidding on and threw on our network model to see how our rail track would be impacted by taking on this additional traffic. The next view of that actually shows how the product is going to be aggregated from some of the origin points up to Atlanta. Atlanta's over here up to Birmingham, and then it's going to run as a block up to our yard in Bellevue, Ohio, where then it gets spread out to Buffalo and Conway and the various other destinations. So similar kind of things that you deal with on a regular basis in terms of your feeder roads and highways and all that stuff. We just happen to have to do it where we own the track. And then that prints detailed reports which can indicate which trains are going to be out of capacity if you take this on. So if we need to add additional train starts to handle the traffic, we know how to do that. We also have yard simulations. So this is an overhead shot of a hump yard. It's not a training class in rail, so I'm not going to spend much time on that, but all those pieces are there and they all have to work together to get the cars sorted out, because the cars don't move by themselves, so we have to have either a hump yard or the locomotives that move them. And of course, as you might guess, from time to time we need to be able to simulate that. So we have models built out where you can adjust the switches. Are they manual, are they automatic? You can add forwarding tracks and other things and try to optimize the throughput through that yard. So very similar kind of stuff. We got a room full of well, half a floor full of PhDs and advanced operations research type folks that build all that stuff so that you can then put in all of your parameters, all your operational considerations, and then do that what-if analysis before you ever started putting down track at, maybe $1 million, a couple $1 million a mile. So you don't want to just do that and then find out later on that that wasn't really what you wanted to do. So all those kinds of things look great. I saw a lot of really great presentations, really great looking information this week here, some just this morning. But maybe you've got your own set of data, you want to get at it, and how do you do that? So I'm going to suggest that if you've got data, you need to get Tableau. And just a little bit about Tableau, since I don't know how many of you are familiar with it or not. Founded in 2003, their founders came from Pixar, so they have a real focus on the visual side of it, using the proper color palettes, those kinds of things, and also from Stanford University that developed the VisQL engine. So instead of having to know a lot of SQL or MDX, if you're hitting a data cube, it's a drag and drop interface. The software creates the SQL or the MDX behind the scenes, sends it off to the server or the underlying data source. You don't need to know any of that. I don't know any of that. But I can do a lot of things with it. So Generally, what's gonna happen, you're gonna have the desktop version of the software, that's where you create the visualizations, and, or Tableau Public, so that might be another option for you. Then from that, you can either publish it to their hosted services, or you can purchase the server yourself and host it for whomever you want to provide access to it with. And it's all interactive. Once it's posted up to the server, and you can interact it with mobile devices, it recognizes those. There's even native Android and iPad versions of the software to interact with it from the server. So, Tableau allows you to really get into the data quickly, interact with it, see what there may be there that you want to know. Again, they've got backgrounds with folks like Stephen Few and kind of the industry experts on data visualization. They've tried to build a lot of the best practices in the software so that you don't necessarily have to know them all yourself. It connects all manner of databases. You can see a long list here. They've got connections to, I think, 3 different versions of Hadoop, as well as Teradata DB2, all the major players from a database standpoint. So if you've got data and you need to connect to it, you can probably do it with Tableau. So, a few supply chain examples. This was a quick little dashboard that was built out. That's not your eyes deceiving you. Some of the data is blurred out just because it's proprietary or sensitive information. But on the left-hand side there, you've got ethanol plants in the United States, and you can see them underneath here, the capacities, those kinds of things. They're color-coded by the fuel source. So it could be corn, it could be switchgrass, it could be brewery middlings, or whatever they get rid of after they've made beer and it still has some sugars left in it. On the right-hand side, you've got a blender demand map. So this is looking at the amount of ethanol that the blenders need to mix with the gasoline at the destination end, because right now if you try to blend it in advance and pipeline it, it picks up water because of the alcohol in it. And then in the middle, so these are both running from either Excel or Access databases. In the middle is actually a view of real-time ethanol loads moving on the NS network by location, sized by volume, running against our Teradata operational data warehouse. So just ways that you can kind of build these views out from various data sources, even if you're not trying to, even if they don't have fields in common, you can build this stuff out. Just another view, simple bar chart, but in this case we were dealing with a customer with a lot of plants, looking at truckload carrier spend, and these bars are color-coded by the plant, or the manufacturing facility. So C.H. Robinson up here gets a lot of volume from one particular plant, but there are some other plants that had no idea, because they all operate independently, that C.H. Robinson was such a big player for them as a corporation. And just the ability to be able to see that allowed them to have more negotiating leverage with that carrier when it came time for them to get rates for the pieces of traffic that Robinson handled for them. Bullet graph, it's another style of graph. And when you look at these things, think of your data. All of you have data where this style of graph could make sense. So in this case, we're looking at the market rate, the average rate per mile for truckload transportation for that particular location, and the bar indicates their actual rate that they're paying. So in some cases, some mills are doing better than the market rate, some mills are doing worse than the market rate. But this could be any time if you've got actual versus planned data, 2012 versus 2013 data, anything where you want to have a comparison, that's a handy way to be able to do that. So that was all of the canned presentation that I was going to do. And I wanted to give you some kind of live examples so you see how this works and how the interactivity works for things that you might want to build out yourself. So in this case, this is a plot of course they have to open up now, they were all opened up before my crash. So this is a plot of locomotive movements based on GPS location information. And the image behind it, rather than using a map, a live map, we actually just took a snapshot of that particular drawing of that location and used that as a background image. So you can do this with buildings, you can do this with all kinds of structures where rather than having to have a live map feed, you can put another image behind that. And then I can just highlight individual locomotive paths through that rail network to see how they did. One of the other things that I could do from this, if I go back into the design mode, I can take this map here, I just did a right mouse click, I'm going to duplicate that sheet. So now I've got the same sheet duplicated. I'm going to take the ID number, drop it in on the pages shelf, and go back into the presentation mode. And now I can just play that, and it will walk through each of those IDs, highlighting the particular train that relates to. But you can do that with anything. You could put regions on the pages shelf. You could put the GPS data so you can actually see the movement of the path of the vehicle. You can do that with date time series information. So if you want to see how does my map change from month to month to month. And you do it as simply as I just did it, which is why I wanted to show it to you there. So let me stop that. Going to move over to another example of data here. Census data. This is another example where we took the percentage of change by county and applied that. So again, if starting back in 1990 or 91 here, you want to be able to see how the population shifts are occurring by county across the United States. You can just play this and see which counties are gaining population, which ones are losing population, which may be significant as you're trying to match that up along with your highway infrastructures, your building plans, those kinds of things. Because not only does that impact all of the local traffic that you may be dealing with, but certainly it's going to impact the corridor traffic, whether that's coming in on truck long haul or say on an intermodal train, however that other kind of traffic gets there. So just another example of how the tool can be used. Okay, 10 minutes. And we have a representative in the room here that works with creating and publishing the freight analysis framework data. And this is a little workbook that was built out. Again, all of this is kind of scrunched because of the difference in screen resolution that just caused my PC to crash. And it's a fairly large database. It took just a little bit to open up. But basically, we've built this out so that you can do freight analysis from the freight analysis framework. You can select which major groups of commodities you want to look at, whether you want to look at domestic or export, which modes of transportation. I've selected pipeline, truck, and rail in this case. At commodity level, you can get down to that 2-digit commodity level with the data. For origin state, I picked Tennessee, which has 3 areas within the state of Tennessee that have been aggregated into the FAF data. So that's just a little background about the data. In the workbook itself, switch to the left here, we actually build in a few pages that are just informational about the workbook. There we go. That was just an overview of the FAF data, what it is, where it came from. There we go. And credits to the data. We've got little information about how the filters in fact work, key functionality, and then the global filters that we just looked at. And then you're on to a view of the data. So in this case, those 3 origin areas that were identified in the state of Tennessee have a little pie chart way too many slices to be of significance other than to show the relative amount of traffic moving in and out of these areas, in this case, and color-coded here. If you want to filter the data, you can use any of these sliders. Say I want to look at only commodities that had at least 34,000 tons. It recalculates the data, it recalculates all the information down below. We're comparing the 2011 tons and the 2007 tons. I think we have a new version of this with the 2012 provisional data in it. But if I wanted to see, well, what is all this, who potentially is handling this stuff, we build in some hyperlinks so that then we could go out and, for instance, pass that information out to a Google search, a Yellow Pages search, Manta search, Hoover search, and kind of see who those customers might be that are dealing with Tennessee plastics and rubber, which is kind of that subcategory of data. So if you were in a sales marketing perspective, for instance, but again, think of this in your own data. If you've got data that has, here are all the trucking companies, and you want to be able to pass that trucking company link out to a website to be able to see who that trucking company is, get right on their website, find out who their contact people are from an emergency or just an informational basis. Very easy to do with this particular application. I'm going to close out of that screen. We're going to go over to...
John,
yes.
can you back up?
Sure.
How did you find the Tennessee plastic?
It was in the commodity group, and all we did was pass the commodity group information, because that was the bar of the graph that I selected. We passed that information along with the Tennessee out to a Yellow Pages search, so that it would search Yellow Pages for those commodities within the state of Tennessee. Now, if you wanted to look at that and refine that to a geographic area, you could just add Knoxville to that and see, well, who's in Knoxville for this commodity in the state of Tennessee. But it's a starting place to get up and running without having to key everything in from scratch.
The reason I asked that question, I'm sorry that I'm...
Sure.
The reason I asked that question is we might have a data breach in terms of confidentiality if you are able to find Tennessee plastic.
Well, I mean, I could do a search for Tennessee plastic on my own from anything. All we're passing is a commodity code. So
Yeah,
there's
but
no
you bring out
there's no
very good
customer
points.
information in
Right.
there.
Right.
It's an open-ended search for anybody that, and the results you're gonna get back from the Yellow Pages, I mean, they're gonna include the local guy that's, I don't know, sells cellophane to,
Yeah. No,
party
I don't mean
stores,
you, but
kind of thing.
this can be something we need to address.
Okay.
Thank you.
But generally, I mean, we're only using the data that's
Right.
there.
Yeah. No.
At the level of detail that it is. In this case, we want to be able to look at those flows. So again, you've got your origin points down here in Tennessee, and right now we've colored the flow by truck and rail, but we could switch that around and color it by, say, major group, so that you can see what that flow is. And if I want to say, well, where are the chemicals going, I can highlight that, see what that is. Again, change the tonnage, change the miles to be able to kind of work through that data. So as a starting point type of tool to be able to understand, because if you just look at the FAF data itself, I mean, it's, I don't know, half a gigabyte of rows and rows of rows and rows. So somehow you got to get your head around it. This was an attempt to be able to get your head around what that data. But, think of your data. Accident data, congestion data, whatever that is. You can build the same kind of thing out. There's nothing magic about what we did. This is just a data set I had to do it and represent it with. One other thing here, then I got to get to my live demo and build this dashboard out for you real time, and hopefully not. I had a number of things that I wanted to show you, but in the interest of time, I've shown you some very specific things that were built out for a purpose. What I'm going to bring up right here is a sampling of workbooks of different types of things that can be done with Tableau. instance, I get back here. If you want to see different types of bar and line charts, there's what those look like. I mean, again, this is sample. A lot of this comes from Tableau Public. There's a public website, again, where bloggers and government institutions can post their data. There's different ways that you can look at maps and geocoding. So you can do some of the heat map, county mapping. The database actually covers worldwide, but obviously our focus tends to be more here. Time series data, so you can see some of the data types that are often represented by some of the statistical packages that you may have seen in the demos this week, and they are able to be done. So you've got tree maps, bubble charts, word clouds that are all kind of built-in possibilities within Tableau. And with that, I'm going to jump and try to build this workbook out on the fly. Let me just close this stuff out so you can see that I got nothing up my sleeves. Other than, I'm going to open up one Word document so I can pull a little bit of code and save me the time of typing it in later on. So I'm going to look at some data here in an Excel spreadsheet that is actually well drill, well rig information from the Marcellus Shale region. And what is that? Okay. So here's the data real quickly. You've got an application number, a job date, the state, county, the operator name, well name, and a latitude and longitude of where the actual well is. So we're going to take that data, and there's a little utility with Tableau that allows you to just do one click and open this data. Okay. Because I crashed, let me try to save this. All right, now we'll open it up in Tableau. So Tableau looks at the data, says which table do you want to open up. This is where you can do your joins or connect other databases, but I'm going to connect live to the data. And it says, okay, these things look like dimensions, and these other things here that look like numbers, we think they probably are numbers, so we're going to call those measures, but you can drag them back and forth wherever you need them. So the first thing I'm going to do is carry state out here. I just drop it there. Okay, we got, those are the three states involved in this set of data from ourselves. And I'm going to put the number of records on there. And so Pennsylvania is the big winner in terms of total numbers out there. And I'm going to add job date. And I look at the job date here and I can see that, 2008, 9, and 10 really didn't have much activity. So I want to get rid of those from my data. So I'm going to put this on the filter shelf, use that same field, turn those off, say OK. And I want to keep it that way for everything else that I do. So I'm going to say use that filter for this data source for everything else that I build out. So there's my data, but I want to see it a little more granular than that. There's quarters, there's months. Okay, I really don't need the quarter information in there because I don't know about quarters anyway. So there's all my data by month, by state. And this has some of the starting point built-in graph types in Tableau. And I'm going to go up here and use a heat map. So now I can kind of see the relative sizes of activity by state, by month, for the number of wells in that particular state. So I'm just going to call that heat map. And I'm going to move on to bringing in the latitude and the longitude that came with our data. And it builds that out in the middle of the state of Pennsylvania. Well, it's using the average lat long, so this is kind of a real cheap way to do a center of gravity model. And just looking at the points right there, it is. So what I need to do is to bring in a little more level of detail. So I'm going to bring in state information, and I'm going to bring in county information. And that's looking okay. I want to bring my number of records up there. I'm going to size those by the number of wells in those areas. That's okay, but some of those areas are, some of those dots are pretty small. So I'm going to change that to a field map. So it's recognized my counties. It's showing me the number of wells in each of those counties. I'm going to take that and put that up on a color shelf, because that's really the level of detail that I need, is just being able to see that, the difference between how many wells are in those areas. So now that I've done that, I'm going to bring this latitude back up there again. I'm just going to create a second map. And on this second map down there, I'm going to change this around a little bit. And what I want to do is, I want to see specifically in the county, where are these wells? So I'm going to change that to circles. And I'm going to color those by operator, because I want to know who's operating where. And I'm going to come down here and I'm just going to change this a little bit. I'm going to make those transparent, because some of them overlap with each other, and I'm going to put a little border around them just so I can see them better. Okay? But I know I have more wells than that, because I have about 2,000 wells in this little data set. So I'm going to bring in the well name to the level of detail. So now I can see all those wells. So now I've got, here's where all the wells are, here's where my counties are. I'm going to go back up here, click dual axis. So now I've got that laid one on top of the other. So I've got my heat map over here, I've got my map there. I'm going to do one more thing, and then I'll make this workbook. I'm going to show the operator, and I'm going to show the well type, whether it's gas or oil, and the number of records. And I'm doing this just by double clicking on these fields. Now, you can drag them up here and drop them on these shelves. You can drop them right on the workspace itself. A lot of different ways you can use the tool. So that I'm going to call table. And I'm going to hit this little icon here and build out a dashboard. So first thing I'm going to do is add my map. So I'm going to double click that. And then I'm going to drag my table over here. So there's my table information. I'm going to bring my heat map up at the top. Slide that up a little bit. I really don't need to have this title up there, so I'm going to hide the title, and I'm going to hide the field label, so now it takes up a lot less space. And what else I got going over here? Okay. Because the screen resolution is so odd, let me select my dashboard, and I'm going to make this, I'm going to make this 728. No, I can move that 1,000. I'll make this for an iPad landscape view. There we go. So I'm going to go back up here. I'm going to tell this to go ahead and fit that the width across the top of the page, because it just makes it a little easier for me to see what the month names are. While I still have it selected, I'm going to say fit the entire view, because I want to see all the information in there. And I'm going to make this a filter. So I'm going to tell it to use it as a filter. And I'm going to come over here. Let me slide it back over so you see what I'm looking at. That doesn't need to be that big. So I slide that out of the way. Again, I'm going to say make this a filter. And I'm going to do one last thing here on this dashboard. I'm going to set up an action on this worksheet. So on this action, I'm going to say I want that to be a URL action. So on sheet 2, which is my map, I'm going to paste in this link here. And in the link is embedded the latitude and the longitude from the database. So anytime I change that, it's going to seed that information. I'm going to make that a select, say OK, and there's my dashboard.
Excuse me,
Yep.
is anyone catching either shuttle to the hotel or to the airport? 12:30, they should be leaving in a few minutes, so
Okay.
anyone
I will
make
be
them?
done in about 120 seconds.
Okay,
So, now that the dashboard's built, I can click on the month name up there and filter that. I can click on the year, it'll filter just to the year's worth of data. I can click on the state of Pennsylvania, and it'll show me just the Pennsylvania data. I can click on Cabot Oil, and hold down my control key, and click on Consolidated Energy, see those things together on my map. And if I want to click on one of these well locations, it'll pass that URL out to Google Maps, and there's the actual overhead image of that well being drilled right next to the river. So,
Awesome.
in less than 10 minutes, there was a fully interactive dashboard that now you could publish to your website if you wanted to see where all of the gas well activity is, where the accidents are. Here's where carcasses were removed. You got the data, you can build it out, and you don't need a staff of, 20 people behind the scenes to do it.
Are you able to publish that out to a web view or something like that? For like
Yes.
the folks?
If you have the server, you can put it on your server and have it linked to your website. You can,
You gotta buy the server product to do that.
well, or if you put it on Tableau Public.
Okay, public,
You can
okay.
put it on Tableau Public and
Got
link it to your website, all those kinds of things.
Yeah.
Thank you all.
Thank you.
very much.